In this video, we're going to be talking about how to graph exponential functions and talk about the characteristics, be able to identify the characteristics. So first, we're going to talk about the definition. When we're dealing with exponential functions, the definition states, let A and B be real number constants, and then an exponential function, is a function written in the form y equals a times b raised to the x power, where a does not equal 0, b is greater than 0, or it's positive, and b does not equal 1. Because if a equals 0, the whole thing would be 0. That would be a constant function or a horizontal line. If b was negative, this wouldn't really work. It would be something else. And then if b equaled 1, 1 to any power is 1. So, or it might be 1 or negative 1. So then we could actually do this. There are some different examples of what exponential functions might look like. And then in order to do this, we really have to be good with our exponent rules. So in number 1, we're given the function y equals 3 to the x. In order to talk about some of the characteristics, we're going to graph it first. So in a normal exponential function, you want at least 5 points. Some you may not be able to do 5, some may be bigger than the graph. But you should try to do at least 5, and these 5 x values are good points to have, -2, -1, 0, 1, and 2. So then, if these are my x values, if I were to put these x values into the function, so for the first one I have -2, so this would be 3 to the -2. Well, my negative exponent rules tell me I take the base, I flip it, and then I make this a positive exponent. So this would be 1/9. When x is -1, same thing, I take the base, I flip it, and I make the exponent positive, so this would be 1/3. Anything to the 0 power is 1. And then 3 to the first power is just 3. 3 to the second power is just 9. So when I graph these, at -2, my point is 1/9, so this is going to be kind of close to the x-axis. At -1 is 1/3, so a little bit higher, but not much. 0, 1. 1, 3, and 2, 9. And then it's going to look like a curve. So I'm going to connect those points. And I'm going to show you what the graph actually looks like. But it's going to look something like this. Where it curves, it gets really close to the x-axis. As we'll see in a table here in a moment, that it gets really close, but it never actually touches or goes past the x-axis. But it will keep going exponentially greater the other way. So let's talk about the characteristics, and then I'll show you this on the table. The y-intercept we see in the table, 0, 1. We also see it on the graph. We haven't really talked about domain yet, but when we get there, this will make more sense. But for now, we need to remember that domain is your x values. And as we're talking about the x values, you're looking at the furthest left x value to the furthest right x value. So on this, this keeps going to the left. The arrow means it's going to keep going to the left all the way to -infinity. And as I follow this function, it keeps going up and slightly right off the function, or off the page, off the graph, and it's going to keep going to the right forever. So it's going to start at -infinity and end at +infinity. Your domain is not going to change for any of your exponential functions. It will always be the same. Your range is your y values. And that's going to be your lowest value, y value, to your highest y value. So I know my highest is definitely going to keep going up towards +infinity. My y's are going up to infinity. But my lowest stops at, like, it gets really, really close to 0. And you're going to ask, how do I know that? I'm going to show you that in the table in just a second. But I'm going to say it starts at 0, but it's not included, so I'm going to use a parenthesis, so think back to our interval notation. And it's going to keep going towards infinity. So in the calculator really quickly, I'm going to put in y equals 3 to the x, and then I'm going to look at the table. And then I'm going to go backwards. And I see that these are really small decimals. It's getting really, really close to 0, but it's never actually saying just 0. Right? Then if I wanted to approximate 3 to the 0.7, I could look at the graph. 0.7 would be somewhere like in here. So I could say maybe that's 2. But I want to find the actual number, so I'm going to put it into my calculator and do 3 to the power of 0.7 to see what it actually is. And I was close. It's 2. Let's say round to 2 or 3 decimal places. 2.16 if rounding to 2, 2.158 if 3. And that just gives you a sense of where could I place this decimal if it fell on the graph. All right, and then we're going to skip around. So number 2 would be similar. I want to do one that has a fraction base. So in number 3, again, we're going to go ahead and graph this, starting with the table, so that exponents are going to work the same. If I have 1/3 to the -2, that would be the same as me taking it, flipping it, and raising it to the +2. So this would equal 9. This would be 3 to the +1. This would just be 1. The next one would just be 1/3, and this would be 1/9 because you square each piece. So then if I graph those, I have -2, 9, -1, 3, 0, 1, and then I'm going to make these smaller, and then 1, 1/3, and 2, 1/9. So if we compare the base, they basically switch directions depending on the base. So if it's a whole number base, it's going to point to the right, go off to the right, or start from the left and go off to the right. But if it's a rational or fraction base, it's going to start, depending on how you're looking at it. If you're looking at it left to right, it's going to start from the left and go to the right. Okay, so y-intercept for this one is, again, be 0, 1. A lot of our exponential functions are going to be that same y-intercept, as long as there's no other things happening in our function. Domain is the same, -infinity to infinity. It keeps going from the left off the graph, and then it keeps going right. And then range, it looks like it's getting really, really close to 0, but it's not going to actually touch it. So again, 0 is 0. It starts at 0, and then it goes to infinity. And that one you have to kind of read weird, because you have to look at, okay, what's your lowest y value, and that's really close to 0, and then your highest y value. And then if I were to approximate this, -1.5 would be somewhere right here. So I could say that's maybe 6.5. And these are just guesses until I actually put it in the calculator. And I was way off, but 5.196. Sorry, my board is a little weird today, but those would be the characteristics and the graph of number 3. Moving on, we're going to go on to, we're going to skip 4 because that's similar. 5 is similar to what we started with. We're going to do number 6 because now we have a negative. So I have to think about this like, okay, the negative is outside of the parentheses, not inside. So what we did before, where we took the base and we flipped it, and made the exponent positive, is still happening, but there's a negative on the outside. So this would be negative 25. If I did the same thing for when x is negative 1, this would be negative 5. Here I have something to the 0 power, so that would be 1 on the inside, but then the negative makes it negative 1. This would just be negative 1/5, and this would be negative 1/25. So then if I graph those, now the negative 2, negative 25, that's way off the graph. I'm not going to be able to graph that one. Negative 1, negative 5, I could graph that one. 0, negative 1. 1, negative 1/5 is going to be like right here. And then 2 and negative 1/25 is even closer. So we'll be talking about transformations later, but you can see that that negative, so if we go back to this, we had something that went this way, and then when we made it a negative, it like flipped, but we'll talk more about those later. So y-intercept for this one would be 0, negative 1. So if you have a negative a value, that's going to change your y-intercept. Domain is still the same, because even though this is going down, this keeps going down and slightly left, and then this keeps going to the right. The range, however, has now changed, because the lowest value, it keeps going down to negative infinity, and then it goes to 0. It's getting really, really close to 0, but it's not actually touching it. If I were to approximate this to the negative 0.5, let's say that's at negative 3. And then if I actually check that in my calculator, was it negative? Yeah, let's see. Whoa. I put negative 5 instead of negative 0.5. That would definitely change things. So negative 2.236. Right. Now we're going to do some others that have other changes. So on to the next page, number 8. Now we have this 3 on the outside. So the inside part works the same. If I have 1/4, I flip that, that'd be, and raise it to the positive second power, that would be 4 to the second power, so 16, which would give me 48. For the next one, if I flip that, raise it to the positive first power, that would be 3 times 4, so 12. 1 to the fourth would be 1, sorry, so that would just be 3. And then the bottom ones are going to give me fractions or decimals. 1 to the fourth, 1/4 to the first power is just 1/4, and then when I multiply it by 3, 3/4. 1/4 squared is 1/16, and then times 3 is 3/16. So when I graph that, again, I can't do negative 248. Negative 112, I can kind of do, it would just be off the graph. Let's say it's somewhere up here. 0, 3. 1 3/4 would be kind of under the 1, and then 2 3/16. Sure, let's use that. So then this, I missed it off, but it's looking kind of like this. So here our y-intercept changed because of the a value. That our y-intercept is now at 0, 3 instead of 0, 1 or 0, negative 1. So that a value is going to change our y-intercept. Domain is still the same. Range is similar to what it was originally. Starts at 0 and then it keeps going up. And then if I were to approximate this at 0.5, let's say that's 2 point something, 3, just because. And I was off, it's 1.5. So the guessing, again, has no real value. It's just to see if you could approximate it based on your graph. All right, we're going to do 9 also, because even though we are still multiplying, we're multiplying by a whole number base. So then, opposite of what we just did, I would take 8, flip it, raise it to the second power. So that would be 2 times 1 over 64. And then we could simplify that to get 1 over 32. This would be 2 times 1 over 8, which would be 1/4. 8 to the 0 is 1, and 2 times 1 is 2. 8 to the first is 8, times 2 is 16. 8 squared is 64, times 2 is 128. So the points on this I can plot -2, 1/32. -1, 1/4. Or does not like the color I'm in. 0, 2. 1/16 is going to be way up there. Let's pretend it's here. So then that y-intercept, because the a value was 2, that's going to be 0, 2. Domain's the same. Range starts at 0 and it keeps going to infinity. And then if I were to approximate it, I'm just going to go ahead and put that into the calculator. So 0.707. I'm sorry, it said to the 10. So 71. Okay, and then we're going to do just a couple more. So as you keep going in this, you'll notice that there's only 2 columns in the table instead of 3, because I want you to be able to fill out your own y values. So we're going to do one of these, and actually the one we're going to do doesn't have any in the values, but we can still put in start at 0, because we have to find our y-intercept anyway, and go backwards. -1, -2, 1, and 2. But with this, we'll have to look at our table in our calculator and put in, what was it, 4 to the x, and then plus 3. And then go to the table, second graph. So you saw a bunch of 3s, and that's going to tell you something. But if we are looking for the values at the table, -2 is 3.0625. If you converted that to a fraction, that would be 49/16. And then when x is -1, 3.25. If you converted that to a fraction, 13/4. When x is 0, so you could probably do this one without the calculator. If I put 0 in for x, that would be 1. 1 plus 3 is 4, but we can double check the calculator just to make sure. And then same thing for the other two. If I put 1 in here, 4 to the first is just 4. 4 plus 3 is 7. And then if I put 2 in here, 4 squared is 16. 16 plus 3 is 19. And we can double check those values. And then when I graph that, I'd have -2, 3.06, -1, 3.25, 0.4, 1.7, 2.19, somewhere way up here. So if you were looking in the table, so this line is a little crooked, it shouldn't be going up like that. If you were looking in the table, that +3 did something. It moved the whole graph up. So the y-intercept is now 0, 4. Domain is still the same. But the range starts at 3 and keeps, going up. And then we're going to do one more of those, and then you'll have time to practice on your own. So in 16, there's a lot of different things going on. So again, I'm going to keep the 5 x values, 0, -1, -2, 1, 2. And then I'm going to put that into my calculator to find what those values would be. And then I'm going to go into my table. Oops, I had graph, so you can see what it looks like. Second table. And I just want these values. So starting at -2, we have -3.875. And if you converted that to a fraction, that would be -31/8. -1 would be -3.75. Or -15/4. If I put 0 in there, I'm going to see if we can do it without the calculator first. So 2 to the 0 is 1. 1 minus 8 is -7. And 1/2 times -7 is -3.5. Or -7/2. And then if I put 1 in there, 2 to the first is 2. 2 minus 8 is -6. And 1/2 times -6 is -3. And then last one, if I put 2 in there, 2 squared is 4. 4 minus 8 is -4. And then 1/2 times -4 is -2. Right, so if I graph those, we have -2, -3.8, so closer to 4. -1, -3.75. 0, -3.5. Those kind of look about the same. 1, -3. 2, -2. If you wanted to plot some more points, you could look back at the table and see that at 3, it goes to 0. 4, it goes to 4. And then 5, it goes to 12. So it looks something like this. That line is a little crooked. So the y-intercept there would be at 0, -3.5. Domain is still the same. And then the range here would start at, let's say the lowest value is -4. If I keep going up, these get really, really close to -4. So start at -4 and keep going to infinity. Also, I wanted to show you this on Desmos just because I keep saying it's getting really, really close to this point, but then you don't actually see it. So let's say I put in that function that we just did, 1 divided by 2, parentheses 2 raised to the x, and then minus 8. So if I'm looking at this function, I'm going to start zooming in at -4. So the more I zoom in, the more I see this line never actually touches -4. It's getting really, really close to it, really, really close to it, and it's never actually touching this line at -4. And you can see that. So let me know if you have any questions, want to go through anything, come see me in office hours, but you have this time to work.